Section 5. Colors, the Embodiment View. Some of the originators of the embodied mind also used the example of color to illustrate their theory of qualia, but came to very different conclusions from those of Dennett. Varela, Thompson, and Roche argue that colors don't exist out there, but are brought forth by the particular nature of our visual systems. They say, quote, "We will not be able to explain color if we seek to locate it in a world independent of our perceptual capacities. Instead, we must locate color in the perceived or experiential world that is brought forth from our history of structural coupling." End quote. Their point here is that different kinds of organism will bring forth different worlds, and this would include Dennett's color-perceiving robot. For Varela, Thompson, and Roche, facts about neurophysiology determine the nature of an organism's color experience. Were the neurophysiological facts to differ, so would the experience of color. As Lawrence Shapiro comments, Varela et al. Conclude that, quote, "Organisms make their worlds. There is no pre-given world that an organism discovers," end quote. Shapiro goes on to say that this bringing forth of worlds is in no way recognized by standard cognitive science, quote. "Indeed, work in computational theories of vision takes for granted a world independent of our perceptual capacities. This is a world of edges, shapes, surfaces, shading, and texture. It is the very independence of the world from our conception of it that makes possible the construction of algorithms that derive depth information from disparity," end quote. In order to try and unpack some of these complex ideas, we can follow Varela et al. When they ask, where is color? They point out that recent computational models of color vision would answer that color can be found in the surface reflectances of objects in our surrounding world. They say, quote, "Thus, it would seem that all the visual system has to do is sample the scene with its 3 color channels and thereby reconstitute the surface reflectances from the activity in these channels. On the basis of these models, several vision scientists, as well as certain philosophers, have argued not only that the function of color vision is the recovery of surface reflectance, but also that color itself is just the property of surface reflectance," end quote. But Varela et al. Object to this realist approach, quote, "which gives rise to several considerable problems, which serve to reinforce our point that the colors we see must be located not in a pre-given world, but rather in the perceived world brought forth from our structural coupling," end quote. They first examined the idea that color is simply surface reflectance. They claim that colors have certain properties and bear certain relations to each other. color varies along the three dimensions of hue, saturation, and brightness. Hues are either unique or binary and are organized into opponent pairs, etc. But they say, quote, if color is just surface reflectance, we should be able to match these features of color with corresponding features of surface reflectance. But there are no such corresponding features, end quote. These properties cannot be found in the structure of light, quote. For these reasons, the properties that specify what colors are simply have no non-experiential physical counterparts, end quote. Second, they say, quote, color is not simply a perceived attribute of surfaces. It is also a perceived attribute of volumes, such as the sky. Furthermore, we experience colors as attributes of afterimages, and in dreams, memories, and synesthesia. The unity among these phenomena is not to be found in some non-experiential physical structure, but rather in color as a form of experience that is constituted through emergent patterns of neuronal activity, end quote. They then considered the idea that the function of color vision is to represent and thereby recover surface reflectance. Firstly, Varela et al. Note that this idea comes not from biological and ecological research into color vision, but from the attempt to engineer artificial systems which can detect objects, including their color. Such systems discount variations in illumination and simply recover the invariant reflectances in a scene. Varela et al. Concede that this engineering research is important and useful, but insist that, quote, it should not be allowed to dictate conclusions about the biological and ecological purposes that natural color vision serves. Indeed, attention to these biological and ecological purposes reveals that color vision is concerned as much with properties that change, such as lighting, weather conditions, and time of day, as with properties that remain constant, such as surface reflectance, end quote. Finally, Varela et al. Identify a, quote, hidden but much deeper problem with the objectivist view of color vision. The objectivist simply assumes that the surface reflectances are to be found in some pre-given world that is independent of our perceptual and cognitive capacities. But how are we to specify what counts as a surface? How are we to specify its edges, boundaries, texture, and orientation, if not in relation to some perceiver for whom these distinctions are relevant? The objectivist supposition that surface reflectances are pre-given rests on the assumption that since surface reflectance is a physical property, it can be measured and specified in entirely physical terms. But although the reflectance at any point in a scene can be specified in physical terms, what counts as a surface may in fact involve tacit reference to a type of perceiver, end quote. They claim that computational models obscure this because they, quote, treat the visual system as if it were simply presented with a certain class of pre-specified objects whose reflectances must then be recovered, end quote. This, they say, results in a considerable and artificial simplification of our actual perceptual situation, quote. The visual system is never simply presented with pre-given objects. On the contrary, the determination of what and where an object is, as well as its surface boundaries, texture, and relative orientation, and hence the overall context of color as a perceived attribute, is a complex process that the visual system must continually achieve. This achievement results from a complex cooperative process involving active dialogue among all the visual modalities. Indeed, color vision is actually involved in the cooperative process by which the visual scene comes to be segmented into a collection of surfaces, end quote. They then quote two researchers who say it's, quote, impossible to separate the object sensed from its color because the color contrast itself, because it is the color contrast itself that forms the object, end quote. Thus, colors and surfaces go together. Both are to be found in our embodied perceptual capacities.